Okay, in this video, we're going to be dealing with graphics in the media. That's section 5D. And in this unit, we will explore some of the more complex types of graphics that are common in the media, along with a few cautions to keep in mind when interpreting graphics. Okay, so here we're going to begin with graphics beyond the basics. Here we're going to look at three different types of graphs here: a multiple bar graph, a multiple line chart, and a stack plot. Okay, first of all, a multiple bar graph has two or more sets of bars that allow comparison between two or more data sets. All of the data sets must have the same category so that they can be displayed on the same graph. Okay, so here is what a multiple bar graph looks like. Here it's got two sets of bars for each category in this case. And here we have a legend that distinguishes which is which. The darker bar is for men and the lighter bar is for women. So that's what a multiple bar graph would look like. And next is the multiple line chart. And this is in cases in which data categories are quantitative. The better choice would be a multiple line chart. And that's what a multiple line chart looks like. And notice the colors here are different. It indicates which is which. Okay, the third is the stack plot. This is what a stack plot would look like. You have different data sets stacked on top of upon one another. And it can be stacked in both bar charts and line charts. So here, this is a stacked bar chart. The bars are stacked on top of each other. And they use different colors here, as you can see, to indicate which is which. Okay. So now we're going to look at some examples of these particular graphs. Like in example 1, here we got a multiple line chart. In this figure, the graphs from top to bottom represent individuals who are not high school graduates, who are high school graduates, who have some college experience or an associate's degree, and who has a bachelor's degree or higher. Here we're going to complete parts A and B below. Now this is what the graph looks like here. And in this case here, from top to bottom, this one is going to be individuals who are not high school graduates. This next one will be high school graduates. This next one has some college experience or an associate's degree. And then the last one has a bachelor's degree or higher. Now we're going to use that to answer parts A and B as I mentioned. Here we're going to briefly describe how the unemployment rate has changed with time over the period shown in the figure. Has the trend in differences between educational attainment level remained consistent during this time? And explain. Here you want to choose the correct answer here. Okay, so here you'll be given a choice of answers here, and you'll have to kind of read over them and pick the one that would best fit that particular graph. So here we want to find that has a trend in differences between educational attainment level remain consistent during the time, and how the unemployment rate has changed with time over the period shown in that figure. In this case, it'll have to be this one, where the unemployment rate varies over the time period. The trend in differences between educational attainment level has remained relatively consistent over this time period, in that more education leads to a smaller unemployment rate since for each year a higher level of education always has an unemployment rate less than educational levels below it. Okay? In other words, what they're saying is this: the more education you have, the less likely that person would be unemployed here. And that makes sense here because at the top, the unemployment rate for someone without a high school education or a high school diploma, that tends to be more than someone who has a bachelor's degree or higher. Okay, and now for part B. For 2006, approximately, how much more likely was a high school dropout to be unemployed than a worker with a bachelor's degree? Well, let's look at that graph. It does say here, and this is for 2006, so I'll be looking at this right here. At 2006 here, at that particular point, it was around, I'm going to say 7% for a high school dropout. But for someone with a bachelor's degree, that's about right here. That's about 3%. So in this case here, a high school dropout would be approximately 2 to 3 times more likely to be unemployed than someone with a bachelor's degree. Okay. All right, let's look at the next example. Here we're going to consider the data displayed in the figure and complete parts A and B below. Okay, so here is that table that deals with test scores. And in part A, which group scored higher on the test? Boys in country D or girls in country F? Estimate the test scores for each group. Let's start off with the boys in country D. Now, here's the graph. The red is the girls and the blue is the boys. Okay? So starting with country D, the blue is going to be the boys, and that's going to be this bar right here for country D. If we read off to the left, this looks like that bar is between 500 and 520, which is about 510. So the boys in country D scored about 510. Now for the girls in country F, we look at the red bar for country F. That's this bar right here. Read it off to the left, you'll see that it's going to be approximately 530. So the girls in country F scored about 530. And in this case here, the blank scored higher on the test. The girls in country D or the boys in country F. In this case here, they're going to give you a choice of answers here. So it's going to be, by looking at this, the girls in country F score higher on the test. So you'll select that one in the drop-down menu. Now in part B, which group scored higher on the test, boys in country B or girls in country E? Okay, so the boys in country B. We look at the blue box here in this case. That's this one right here. Read it off to the left, you'll see it's about, let's say, 550. So the boys in country B scored about 550. And then the girls in country E. Here's E. The girls are in red. And then read to the left. That's about 540. Yeah, about 540. So the girls in country E scored about 540. Now compare those two. You can see that who scored higher on the test, it would be the boys in country B. That would be that answer choice. Okay. All right, next we'll look at another multiple bar graph like this one. The table to the right gives data for boys and girls in 6 countries who took a science test in 2012. Make a double bar graph for these data with the vertical axis running from 460 to 560. Okay. In this case here, this is what the table looks like, and you'll be given a choice of graphs that would fit that particular table. Okay, now what I'm going to do here is use what they call process of elimination to determine which one fits that particular graph. In this case, if I look at country A, notice the mean for the boys is 498 and the mean for the girls is 509. That will mean the bar for the girls has to be taller than the bar for men, for boys. Sorry. Okay, and we have to look at the legend very carefully here. Like in A, the blue is for girls and the red is for boys. For country A, we can see this one is taller than the second one. But if I look at the mean for girls, that's 509. This bar is way past 500. Okay, so I can eliminate A altogether. Now, what about B? Well, here, they're letting the blue be boys and the red be girls. Here, the bar for the girls has to be taller than the bar for the boys in country A. That's not the case here, because this bar represents the boys, this bar represents the girls. This has to be taller than the one for the boys. That's not the case. So here, B is excluded. I think C and D looks good, because if you look at country A, let's see, actually, if I look at D, and you have to pay close attention to the legend here, they're letting the red bar be boys and the blue bar be girls. The girls have the bar for the girls has to be taller than the bar for the boys in country A. Here, based on this legend, that's not the case. So guess what? It's answer C. Okay, and I think that has some type of magnifying glass so you can blow up that particular, each bar graph to see which one would fit this particular table. Okay, let's look at the next example here. This deals with a stacked bar chart. So here we're going to use the data in the graph to complete parts A and B below. And this is that stacked bar chart that we will use here to answer A and B in this particular example. Okay, so here in part A, which cost category varies the least among the different types of colleges? Can you explain why this category varies so little? Okay. In this case, we need to find which one of these varies. And as you can see here, the dark blue represents tuition and fees, the light blue, room and board, the green, other expenses, the yellow, transportation, and the red, books and supplies. Okay, we can eliminate the tuition and fees. That's this dark blue box right here, because there is a large variation between all of those institutions here. And also we can eliminate this light blue right here, the room and board, because that definitely will vary. But we have to look at the red, the yellow, and the green and find out which one varies the least. Let's start off with the red that says books and supplies. I'm going to label this B and S. I'm going to take the largest dollar amount for books and supplies of the four minus the smallest amount for books and supplies of those four and find out what that difference is going to be. The largest here for books and supplies, we got $13.91, $12.51, another $12.51, and $12.33. Here, the largest is $13.91 minus the smallest, which was $12.33. If you subtract $13.91 minus $12.33, you're going to get $153. So books and supplies vary by $153. Okay, let's also look at transportation. I'm going to label that as T, and I'm labeling B and S as books and supplies. For transportation, that's the yellow box. We got $13.64, $11.13, $11.13, and $1,098. Okay, and that's $13.44. That's the largest, $13.44, minus the smallest, which is $1,098. Subtract $1,098 from $13.44, you're going to get $246. So transportation varies by $246. And then we got other expenses, which is the green box. You got $21.50 here, $2,092 here, another $2,092, and then $1,572. The largest is $21.50 minus the smallest is $1,572. Subtract $1,572 from $21.50, you're going to get $578. So which one varies the least? It's this one. That has the smallest difference here. So here, books and supplies, which I can check off right here. Again, you'll have a drop-down menu to select which one is which. So here, books and supplies varies the least and has a variation of $153. And then the question after that is, why does this category vary so little? Well, we have to pick the answer that deals with books and supplies. And it has to be answer C. Because books and supplies varies the least because students at all types of colleges need approximately the same number of books and supplies, and these don't vary much in cost. Okay. Now, part B, ignoring the other expenses category, the general trend is for all categories to cost more as you look down the chart from 2-year public colleges to 4-year private colleges. However, one category is an exception to this trend. Which category, and can you explain why? Well, by looking at this, it will have to be transportation. The reason for that is because commuters must spend more money to get to school than students who live on campus, and that does make sense. Because if you're living on campus, then pretty much you don't have to do much traveling. Well, you'll have to walk, but you're not going to use gasoline to get to work. To get to your classes. But for those who commute, who live off campus, yeah, you have to spend money just to get to school. Okay, so that's one of those stacked bar graphs and what they look like. Here's another example. This one is one of those stacked line charts. In this case here, it shows the number of college degrees awarded to men and women over time. Complete parts A through D. And in part A, we want to estimate the number of college degrees awarded to men and to women separately in 1990. Okay? And the key word there is separately in that particular problem. So let's find out the number of college degrees awarded to men in 1990. And here you're given a choice of answers here. These are the choices here for that. By looking at this for 1990, you're going to see that line right here, that point right here is going to be between 5 and 6. And this is in 100,000, so it's between 500,000 and 600,000. And by looking at these answer choices right here, the only number that's between 500,000 and 600,000 would be this number right here, 555,500. So you'll pick that, whatever they give you as the answer choice. And then the number of college degrees awarded to women in 1990, it's going to be one of these choices right here. And let's look at this. For 1990, that point is right up here, and it's between 11 and 12. That means it's between 1,100,000 and 1,200,000. Okay? Now, do keep in mind that this point represents all of this. This shaded area between this point and that point is representation of women. That's the dark red. The blue is for men. Keep that in mind. So we need to find out what this is separately for women. We need to subtract this point minus from this point to find out the number of college degrees for women. And if this is about, let's say, 1,100,500, I'm just estimating, 1,150,000 minus that amount of 555,500. Okay. So if I subtract those two, 1,150,000 minus 555,500, this will end up being 594,500. So in this case here, I will have to pick a number that's closest to 594,500. That will have to be this number right here, 563,500. Okay. Now, part B, about when were the number of bachelor's degrees equal for males and females. Okay. Well, we know in the 1960s there were more men with bachelor's degrees than women, and in the 70s there were more men with bachelor's degrees than women again. And then this started to pick up, but here you can see more men than women with bachelor's degrees. But here, in 1990, they're about equal. So we're going to say around 1990, they were approximately equal. Okay, that's when the number of bachelor's degrees were equal for males and females. Okay. Now, part C, during what decade did the total number of degrees increase the most? During what decade? Between 1960 and 1970, notice a sharp increase. The slope increased. The slope is bigger. That means that there is an increase here in college degrees, college bachelor's degrees. So it was during the 1960s when that happened, when there was a sharp increase, the most in bachelor's degrees. Now, part D, do you think that the stack plot is an effective way to display these data? Briefly discuss the other graphics that might have been used instead, and choose the correct answer below. Well, by looking at this, I would say, while the stack chart makes it easy to see the changing total, a double bar graph would be better, because with this you can make a male-female comparison of the two. Okay, so I would rather use a bar graph than a stacked line chart. Okay, if I want to make comparisons between males and females, and maybe that might be best if I wanted to better answer those questions, parts A, B, and C, more effectively. Okay, next we'll look at graphs of geographical data. I'll just talk about these. We won't do a lot of examples on these, but I'll just talk about those because these are found in real life here. We are often interested in geographical patterns in data. The graph below shows one way of displaying geographical data. In this case, the map shows trends in energy using per capita proportion in different states. The actual data values are shown in small print with each state, while the color coding shows the bin categories listed in the legend. Okay, so here is the graph, and you can see how color coded it is based on this particular legend. So we're looking at per person energy use by state, and that's going to be in gallons of oil equivalent. You'll see that legend, and you see where those fit. Okay, next is this contour map of temperature. This is what meteorologists use when they're predicting the temperatures across the state. Okay, that's what they use here. You can see in this case you got widely separated contours. That means large regions have nearly the same temperature, and then if you have closely packed contours, that means a large temperature difference over a short distance. Okay. All right, next we'll look at three-dimensional graphics. Computer software makes it easy to give almost any graph a three-dimensional appearance. It allows us to show richer data sets. However, it can be difficult to read the data precisely. Three-dimensional graphics therefore tend to work best when they are interactive or online, so that figures can be rotated or viewed from different perspectives. And here is what a 3D or three-dimensional graph will look like. You can see you got your horizontal axis here for the year. Here you got the country, and then vertically the CO2 emissions. Okay. All right, now, the example that we're going to go over is going to be dealing with this particular figure, where you have college is a valuable experience. Okay, that's what the picture looks like, and here's the rest of it right here because I couldn't get it all on this particular screen. Okay. Now we're going to use that to answer parts A and B of example 6. In this case here, what percentage of students do not party at least 3 hours per week? Okay. Now, in this particular graphic right here, if you look down here, it does say here, but college isn't all about the classroom for at least 3 hours a week. And it says here 31% partied. We want to find out the percentage of those who do not party at least 3 hours a week. Well, let's do this. Out of all the students, we're going to use 100%. We found that 31% partied. So if I subtract 31% from 100%, you'll get 69%. So that means 69% do not party at least 3 hours per week. And now part B, the graphic shown shows two different percentages for categories that mention relevance of coursework. Is this a contradiction? Why or why not? Okay, so if I go back to this, okay, it does say here, 58% feel their coursework was relevant to everyday life. And then there's also another percentage somewhere. Yeah, 62% are satisfied with the relevance of coursework to their future career goals. Actually, that's not a contradiction right here between those two. Okay, so here we can say one refers to relevance to future careers, the other refers to everyday life. So there's no contradiction there, okay? Because you can say, coursework that you take has to be relevant to whatever career that you're going into, okay? But not necessarily to everyday life, so there's no contradiction there. Okay. All right, next we'll look at, we'll just talk about a few cautions about graphics, and that'll be the last thing we'll talk about here in this section. Perceptual distortions are this. Many graphics are drawn in a way that distorts our perception of them. And also you want to watch for scales. It can be visually deceptive if you do not study the scales carefully. And percentage change graphs. Graphs that show percentage change can be misleading unless you interpret them with great care. And pictographs. Here, pictographs are graphs embellished with additional artwork. The artwork may make the graph more appealing, but it can distract or mislead. Okay, so here's a perceptual distortion. For example, here, the lengths of the dollars represent the data, but your eyes tend to focus on the area. Here you can see it may represent that data, but if you look at it, if you look at the area, it can be deceptive. Okay. Also, different vertical scales. Notice the first one on the left, that vertical scale starts at 30 and ends in 60. And as you can see how that graph is, that can be deceiving unless you start at 0 on the vertical scale. all the way up to 100. You can see the big difference there. Here, both graphs show the same data, but they look very different because their vertical scales have different ranges. Okay. And finally, what about different horizontal scales? Here's an illustration of that. By looking at that, it appears that the world population has been rising linearly. However, the time intervals on the horizontal axis are not uniform in size. They're kind of inconsistent here, okay? There's no consistency here. From 1804 to 1927, that's like 23 years. And then from 1927 to 1960, 33. 1960 to 1974, 14 years. That's inconsistent on the horizontal scale. Okay, so you do want to be aware of how these graphs can be misleading and it can be deceptive. Okay, so that's going to complete this video on graphics in the media.